Hello friends and my dear students, as in the last session we have discussed about strength rating of warm gear drive. Okay, so today we will try to solve one numerical so that you can understand what are the questions asked in the university exams. So because on the basis of gear design or in the unit number 5, most of the time in the university they will give you one numerical and you have to solve that numerical instead of asking the theories related questions. Okay, so as you can see in the example number 20.5, a pair of worm and worm wheel is designated as 1/30/10/10, means this is the specification or designation given on the picture. Okay, the input speed of the worm is given as 1200 rpm. The worm wheel is made up of centrifugally cast and phosphorus branch, while the worm is made of case hardened carbon steel 14C6, means worm wheel is made up of phosphorus branch and worm is made up of case hardened. Okay, and phosphorus branch with centrifugally casting method or centrifugal casting method. Now you have to determine the power transmission capacity based on beam strength. So on the basis of beam strength you can see that this rpm for the worm and worm wheel, both the things are given, and number of teeth for the worm is Z1, which is 1, and Z2, which is 30 teeth. These two teeth are given as with the help of this particular designation of worm and worm wheel drive. Now first of all, only the input speed of the worm is given, so what you have to do, you have to calculate the speed of worm wheel with the help of speed ratio, which is Z1 by Z2, which is 30:1, which is given in the numerical. So on the basis of that you got to know that if N1 is 1200 rpm, then the value of N2 will be 40 rpm, means for the worm wheel the speed rpm will be 40. Okay, now Z2, which is the pitch circle diameter of worm wheel drive or worm wheel, so that will be M module multiplied with the number of teeth of worm wheel, so that will be equals to 10 multiplied with 30, then you will get the value as pitch circle diameter of the worm wheel as 300 mm. Now what you have to calculate, you have to calculate the lead angle, which is 10 with the help of 10 gamma, which is Z1 by Q. Q is what? Quotient, and the value of Q you can get it with the help of this particular notations at this point. This is Q. Okay, so the value of module and Q, which is quotient, that value is same, 10 and 10. So Z1 by Z1, which is this value, Z1 is 1, Z2 is 30, M is 10 and Q is 10. Now when you will keep the value of Z1 as 1 and Q value as 10, then you will get your answer as 0.1, and when you will take the inverse of this value, means 10 inverse 0.1, then you will get the value of lead angle as 5.71. Now what you have to do, now you have to calculate the value of your respective different data, which we have discussed in the formulas, that you have to calculate the value of torque MT1 and MT2. On the basis of that, there are various factors: XB1, which is your speed factor, SB1, which is your bending stress factor, and LR, which is your length of the root, D2 is your pitch circle diameter, then the lead angle we have already calculated. Now you have to calculate the value of XB1, and before that LR and SB1. So let's see that how we have to proceed in this particular numerical. So for the calculation of LR, you must have to calculate these values: DA1, addendum of worm, C, clearance value, and F, which is the value of F is 2m under root Q plus 1. So with the help of this formula you can calculate, and DA1 you can calculate it by M into Q plus 2. So on the basis of this you can calculate these values of LR, which is the root length of the worm wheel, and after calculation of this you have to calculate the value of SB1 and SB2. So on the basis of this table, you can also get it from design data book, that they have given you a worm wheel made up of phosphorus branch centrifugally cast. So the value of SB1 will be 7, and your worm is made up of case hardened carbon steel 14C6. So the value of SB2 will be 28.20. So let's see, they have kept the correct value over here. So the value of SB1 as 28.2, correct, and centrifugally cast phosphorus branch SB2 will be 7. So these two values you have to keep it. Now you have to calculate the value of speed factor, which is on the basis of speed. So for the value N1, which is the speed of worm, 1200 rpm, and N2 is 40 rpm. So let's see, for 40 rpm, this is 20 and this is 60. So in between this line will be 40. So if you will take the diagonal, then you will reach here. So this is 0.4, means it is between 0.4 to 0.5, but nearer to 0.5, so it will be 0.475 you can keep, or you may keep 0.48. Okay, now let's see for the 1200 rpm. So the 1200 rpm will come between 1000 to 2000, so it will be nearby here, and just drop it perpendicular, so you will get this value as 0.25, in between of 0.25 and 0.3. So the value of xb1 and xb2 you have calculated. Now you have to keep these value in the formula mt1 and mt2. Then you will get the values of mt1 and mt2. And after calculation of this, you have to check that which is lower. The lower value will be the maximum permissible torque. And on the basis of that maximum permissible torque, you can calculate the value of power transmission, which is 2 pi n2 and mt. And do not misconcept this thing that here it is N2, then always MT2 will come. No, you have to calculate the torque for the worm and calculate the torque for the worm wheel, but always keep the value which is lower among these two values here. But the speed will be NT2 only, not N1. If you are keeping the lower value of MT1, then you are keeping N1. No, you have to keep here value as N2, which is the revolution speed of worm, because you are calculating or evaluating all the designing criteria on the basis of worm only. Okay, so thank you so much for your patience hearing. If you like the content, just hit the like button of this video, and we will come up with the next topic of wear rating of worm drive, which will be the last topic of this unit for number 5 of your design of machine element 2 syllabus of BTECH Mechanical Engineering third year 6th semester of Rajasthan Technical University. Thank you so much for your patience hearing. If you have not subscribed this Engineering College Banswara YouTube channel, do subscribe and hit the like button for more such update about different branches of engineering like mechanical, electrical, civil and computer science engineering. Thank you.